What's up, Node.js developers? Welcome back to a new tutorial. Today, I have prepared something exciting for you. Today, we are actually going to build Flappy Bird in React Native using Skia gesture handler and some physics. So this is a little and fun tutorial that is going to help you get started with React Native Skia in React Native. Let's get started because it's going to be fun. Let's run the intro. So, without wasting a lot of time, here is the proof of concept, but we're gonna start everything from scratch and we're gonna do it together. For that, we're gonna, of course, use Expo for our React Native application, and we are going to use React Native Skia because I've been wanting to use React Native Skia for a very long time, but never found like the right time for it. So let's go ahead and open up a terminal and start by initializing a brand new project. I'm gonna do that with npx expo, not expo, but create expo up at latest to take the latest version of Expo, and let's go ahead and name it Flappy Bird. Now Expo will download the project, will set up a brand new project for us, and we're gonna be ready to get started. While this is happening, let's go ahead and find the Shopify/React Native Skia package. Shout out to Shopify and William for making this library possible. Let's go ahead and open the documentation. And if you're not familiar with React Native Skia, this is a way to use the Skia graphics library. And the Skia graphics library is actually powering some of the most powerful engines out there. For example, it's powering Google Chrome, Chrome OS, Android. It's powering Flutter and a lot more browsers. So the way it works is basically it is rendering pixels on the screen in a very easy way to explain it. For mobile applications, if we talk about like Flutter versus React Native, in a lot of cases, we don't want to treat our native application as a game, let's say, and basically render every pixels ourselves. That's how Flutter is rendering the user interface, while React Native is actually using native components like buttons, text, and so on. This is very good in terms of using this kind of native components when rendering user interfaces, but for very specific use cases where we need control over the pixels on our screen, React Native Skia is here to help us do just that. So we get a blank canvas, and on that canvas we can paint, we can animate, we can do everything with those pixels that we can imagine. So this opens up the doors to a lot of interesting projects, a lot of things that were previously not possible, specifically around, I don't know, like games, charts, working with graphics. And actually, I already have a couple of ideas of some kind of creative programming projects where we could render some interesting stuff. We could play with maps and so on. But let's see. Our Expo project is set up and installed. Let's go ahead and open it in Visual Studio Code. Here it is. Come on. And after we have it here, I'm going to run this application to see it on the device. So let's go ahead and start with npm start. This will start the development server. I'm gonna close Expo Go. And I'm gonna probably go ahead and close my previous one. Yeah, let me close the previous one. I don't need it anymore. And here, run again npm start. Hello, everyone who is joining us live. How are you doing, guys? By the way, I forgot to mention, stay tuned till the end of this video because at the end we're gonna do the giveaway that we have promised to do for the survey that we were running. So we're gonna do that in today's video and we will announce it on our social medias. So let's go ahead and we see here the terminal. Let's run the application, and at the beginning, if we open up.js, we should simply see a text rendered on the screen. Did I do something wrong? No, here it is. The text is rendered on the screen. My VS Code is complaining about this, so I will simply press on. Let me see if you can also see it here. I'll simply press on this icon and press configure gsconfig. This will create a new file, gsconfig. And here under JSX, I'm gonna do React Native JSX. Now everything is working fine and we are ready to start working. If I'm gonna go ahead and change this text to hello there, it's going to automatically be changed on our screen as well. So we have a blank application, a blank React Native application. Let's go ahead and set up and install React Native Skia. Let's open the documentation. And in the installation, all we have to do is basically take the name of this package at Shopify/React Native Skia, open up our terminal, open a new terminal, and do npx expo install, and then the name at Shopify/React Native Skia. And because React Native Skia is built in or part of the Expo Go, we don't have to pre-build anything. We can continue using Expo Go application to test our application, being it on our simulator or by simply scanning this QR code with our physical device using Expo Go on our iOS or Android devices. So now that we installed it, I think we can go ahead and do copy-paste the hello world and see if it works. So I'm going to copy-paste, let's copy-paste everything from here, go back to our application. In app.js, let's remove everything and paste the hello world provided by React Native Skia. If I do that, I should already see, without doing anything more, I should already see the 3 circles rendered on the screen. And as you can see, they also have some kind of a blend mode where the color is blending between each other. So perfect. That means that our React Native Skia was installed correctly and we can render a canvas here. If I'm gonna go ahead and do a background color red here for the canvas, we see that the canvas is has this width and height. What I want to do is for a game, usually the canvas is full screen. If you are integrating React Native Skia in a different application where you need the canvas to be a small UI component, you can do that perfectly fine. For example, in one of my other applications, I'm using React Native Skia for graphs. So the graph is just one simple component of my whole application. But because today we're gonna build a game, we're gonna build Flappy Bird, our canvas should be the whole screen. So let me go ahead and import the hook use Windows dimensions from React Native. And I can also remove the import React. We don't need that anymore. And I'm gonna take the width and the height from the use window dimension. So I'm gonna remove them from here. And let's do const equal use window dimensions. And let's take width and height from this value. Now the width and the height is the sizes of the screen, and it will also automatically resize when we change orientation, because it's a hook, so it will automatically update as the window sizes changes. And I think, if I'm not mistaken, maybe it's not out of the box. Yeah, we would have to set up the web. Maybe we can do it at the end to check it also on the web. But for now, I'm gonna leave it like this. So what do we have now? We have the canvas that expands on the whole screen, and inside this canvas we can draw stuff. At the moment it's drawing these circles. I can probably go ahead and get rid of them, because in the next step, you see the background color doesn't auto refresh. I should do reload by focusing on the simulator and doing RR, or by simply pressing R in my terminal. And now it's the styles are reset as well. Yeah, I removed everything that's rendering there, because in the Flappy Bird, I'd like to start by rendering a background image. For the assets that we're gonna use, I found a GitHub repository. I searched Flappy Bird assets, and there is this GitHub repository with the sprites, with all the assets that we would need today. So let's go ahead and press download zip, and somewhere there, give me just 1 second to find it properly. Yeah. And after you unzip and open this one here, you will find the following assets. One of them is this sprites folder that contains sprites or images that we will need. So let's drag and drop the sprites inside the assets. So now our assets folder in our project contains the sprites, and one of the sprites that we are interested in is in this background day or even background night .png. So let's go ahead and check the documentation on how we can render an image in React Native Skia. I'm gonna go to the image documentation, and we see that first of all we need to load the image using the use image hook, and after that, using the image component, we can render it. So that means that first we have to import some of the stuff from React Native Skia. I don't need the circle and the group at this moment. I'm gonna remove them. Instead, I need the use image hook to load the image and the image component to render it. Now at the top of the application, let's go ahead and load the background image using the use image hook. And here we're gonna use the require and provide the relative path to our sprite, our image itself. So because we are in app.js, we need to go inside assets. So from this directory, go inside assets, then go inside sprites, then take the background day.png. Double check to have proper naming here. And after we have this background image loaded, we can go ahead and try rendering it inside the canvas using the image component. So image background, we already see it. That's perfectly, that's perfect. Now we can give this image what is our required property. Is it the React is declared here? Let's check if I can do fit cover the whole space, if that would work. No, because it also needs the width. So the width in our case should match the width of the screen. So let's take width equal width, and it still doesn't work. And if I do height equal height, now it works. Why with only width it didn't work? That's a bit strange. But anyway, if I have both width and height, which I should, anyway, I should, it renders full screen. We can also adjust how we want to fit the image inside the container that we define with this size. And I want it to cover in order to take the whole space. Because if I do contain here, which I think is the default one, we're gonna see that the aspect ratio of my phone and the aspect ratio of the image is different. So I have a white bars here. So that's why I use the cover style here. Perfect. So now that we have the background rendered on the screen. Perfect. Now we have a background. Then we need to render what? We need to render the bird itself. Let's go ahead and import it. So first of all, we're going to need to import the image of a bird using use image, and then require, and we need the path to the image. So let's take it as assets, sprites, and the sprite is called, I think, yellow bird or red. Which is the standard one? Red or yellow? I don't know. Let's take the yellow bird upflap.png. So the name, make sure to take the name correctly. And let's go ahead and render it on the screen. I'm gonna render the image. For the image, I'm gonna render bird. It should be here at the top left of the screen. We can adjust where we want to render on the canvas by positioning the X or the Y, let's say, to be middle of the screen. So the middle of the screen would be height divided by 2. Now if I reload, it doesn't show up there. Should I also give an X, Y, and X? And it doesn't want to move. Well, I think it wants the other like width and height. So let me check what's the width. I think the width of 52 or something like that. And the height of that image, I can check that by looking, revealing in Finder, scrolling, it's 32 by 24. So it's 32 width by 24 height. Okay, so now that I provided the props that it needs, I would expect actually for it to take, let's say, default 1. So if I don't provide height, I would expect it to take height 0. But if I don't provide the height, it doesn't even take the width or the X and Y. So I need to provide all of them in order for it to properly position on the screen. And for this one, the feet should be probably contained because I want the whole bird to be visible on the screen. And for example, I can also make it a little bit bigger by increasing the size twice. So from 32, maybe we should go 64 and height 48. Yeah, let's see. So the X in our case is 120. We hard-coded this one. If we want it in the middle of the screen, we should probably do width divided by 2. Which actually is not actually the middle of the screen, because here we are specifying the X and Y of the top left corner of this image. So if the image would be very large, you're gonna see that we are positioning in the center the middle of a bird. So probably a better way, like if you really want to center it, is height divided by 2 minus half of the width of the bird. And the width of the bird is 64, so minus 32. And here, I mean height. Height is 48, so minus 24. And minus half of the width, 32. So now it's exactly in the center. And again, I'm not sure if Flappy Bird should be in the center on the X axis, so I should probably do width divided by 3 to move it a little bit to the left, or even 4, just for us to see like what's coming in front of us. What do you say? I think that makes a lot more sense. And for the Y, I don't think we need to overcomplicate it, because the Y is going to be dynamic, because we will want to move the bird up and down. Okay, so now we have a background, we have a bird. Hello everyone in the live chat. Tiago, hello. Go full stack. Chrome uses Skia. Elite Coder, hello. How are you doing, guys? Rogelio, Khalid. All right, guys. So now we have the bird on the screen. Probably the next step is going to be to add the, how are they called? The pipes, right? The green pipes. So the green pipe, pipegreen.png. Let's go ahead and load it. So let's go ahead and start by doing const pipe equal use image, and here I'm going to import it with require from assets, sprites, and then the name of the sprite I think is green or pipe-green png. So pipe-green.png. Let's go ahead and render it. So maybe I should add some comments. Bird, background, and the pipes should be rendered before the bird because they are kind of part of the background, right? So let's do pipes here. So I'm gonna render the image of our pipe. Let's see it. Not Spring, but sprites. Come on. So we see the sprite rendered top left corner. If I want to render it at the bottom, what should we do? We should do, hey, render it, the Y position should be equal to the height of the screen. The X is going to be 0 so far. Then we need the width and the height, right? So let's double check the width and the height of these red and green pipes. I'm gonna open this image here and I'm gonna check that the width is 52, the height is 320. 52, 320. But the problem is that moving the Y to the bottom there moved it too much. We need to move it by height minus the height of a screen minus the height of a pipe. So the height of a pipe is 320. So if I do minus 320 here, I should have exactly what I want. But again, I think if I zoomed in twice my birdie, I think I should zoom in twice or make twice as large my pipes. So I think I should do 104 by 640. And the height, if I do 320, that's okay. If I do 640, that's going to be, the bottom is going to touch my bottom of the screen, which I don't really want. I will be able to move it up and down like this. Now I should do the same for the second one. Maybe for the X I can do screen width divided by 2 to have it in the center. We'll see. This is also going to change. Now I need the second pipe at the top. So the second pipe at the top like this, but in this case the Y is going to be 0. Maybe even minus 320. Just like this to move it a little bit up the screen, over the screen. And everything else will probably be the same, right? Yep. Oh, now the challenge is to the challenge is going to be to revert the image. You would be able to do that directly in Skia using a group and some transformations. But in order to not to overcomplicate it right now, because I was trying and it's a bit tricky to work with origins and so on, I would go ahead and simply open my sprites in Finder. I would go ahead, I would find the pipe green. I will duplicate the pipe green, create a copy with it. I will call it pipe green dash top. I would open it up and simply do boom, boom, save. And just like that, I simply have an image that is actually mirrored. And yes, I would have to load two different images. It's not very pipe and pipe top, pipe green dash top. It's not very efficient, but it's fast and I like that. So the image here is going to be pipe top. And maybe I should first render the pipe top and then the pipe, which maybe should be pipe bottom. Like that. And just like that, we have two pipes exactly how we wanted them to look. Okay. Now that we are here on the pipes, let me declare the let me fix these red warnings, because you might think that you have an error, but this is not an error. This is basically TypeScript not knowing that, hey, there is a .png type of file. So let me quickly search on Stack Overflow how to fix it. I just need to declare a TypeScript declaration file, png. So I would have to simply create somewhere here types.d.ts. Actually, I'm not even using TypeScript, I'm using JavaScript, but anyway, and declare that there is a file type with .png, and now my error disappeared. Okay. I don't need this R any longer, so I can have it like this. And yes, as I was saying, we have these pipes. I'm thinking about way to be able to move both of the pipes up and down depending on a constant or depending on a value, and I would do it actually right now. So let's have a value of pipe offset, which is going to be equal to 0 initially. So if pipe offset is 0, I want the gap to be perfectly centered. So how I'm gonna do it is going to be pipe offset minus 320 minus pipe offset, or pipe offset minus 300. Let's try pipe offset minus 320. And here for the Y, it's gonna be height minus 320. Well, let me move this pipe offset by 100 and see what's happening. So if it's 100, it's gonna go down. If it's minus 100, it's gonna go up. Now it should also affect the Y for the second pipe. Should I also do minus pipe offset because it's in the other direction? Here it's with plus, here it's with minus. And now if I'm gonna have 100, will both of them move in the same direction? No, that's what I didn't want to happen. In this situation, they're simply closing up. So probably I should do plus pipe offset. Yes. Now if it's minus 100, they're moving both to the bottom, minus 100 both to the top. Okay, so I'm gonna leave it with pipe offset 0 to have it in the center. Okay. All right, so we have a pipes, we have a bird, the background. I think what we are actually missing is the ground. And if we look in the assets, in the sprites, I think they also have this base.png. Let's go ahead and finally render the base. Const base equal use image, require assets sprites base png. And let's go ahead and probably we'll see, because if we render it before the pipes will be on top, I think. So image equal base. I want the width of this image to be the width of the screen, and the height, I don't know, 300 or something like that. Maybe 300 is even too much. 200, 100. Yeah, maybe 100 is okay, but the Y value should be the screen height. I want to move it to the bottom, but I will subtract from there the half of the height of a base, so minus 50. And X is going to be 0, of course. Now the base is somewhere there, and by simply doing a fit cover, it should cover the available space. And as I said, this one should move to below the pipes, so that the pipe is behind the ground. And maybe the height should be 150, and here 75, something like this. Yeah, probably that's better. Okay, that's good. That's looking like Flappy Bird already. I'm gonna go ahead and actually do a git status, git add, git commit, set up the base assets of Flappy Bird, because we have a base, the base thing, like the fundamentals. Now the next step is going to be to start moving things around, to start animating things, and this is where the fun part begins. We're gonna move things around using React Native Reanimated. If you go to React Native Skia, add the animations, we will see that React Native Skia offers first-class integration with Reanimated. So that means that it's optimized, and we can pass to React Native Skia components, we can pass animated views, and it will work out of the box without us having to basically create some adapters for it. So let's go ahead and open Reanimated in a new tab and go ahead and install it in our application. I think with Reanimated, we don't need a lot of things. We will just do npx expo install React Native Reanimated. Npx expo install React Native Reanimated. And we actually, we have to add the plugin under the plugins in the babel.config. So back in our code, in our Babel config file, after the presets, let's add the plugins. Which is an array. We're going to remove these 3 dots. And if you have other plugins, simply add React Native Reanimated at the bottom of the list. If not, just simply add plugins array with Reanimated there. Now we would have to go back where our application is running, stop it, and start it with -- space -- clear to clear the cache and make sure that everything is working correctly. Let's go ahead and open it in iOS. Reanimated is also included in Expo Go, so we don't have to pre-build anything. We can continue using Expo Go, and we're going to continue using it by the end of the tutorial. Everything is still working fine, which I like. So let's go ahead and do what? We don't have to do anything else. We can already start animating things. So we're gonna start with animating the pipes. And here, let me explain a little bit how a lot of games are working. Because when we think about the movement of Flappy Bird, let's Flappy online. We think that actually we as a bird are moving on a map, right? We are the X position of a bird is moving, and everything else remains static. Well, you can accomplish that, but that would be a bit more challenging because first of all, you'd have to move a bird and you'll also have to think about the camera and move the camera around. But if you switch like how you think about it and consider the bird static on the X, and instead the pipes and everything else moving towards the bird, then it's going to be much more easier because the bird is going to be static, the camera is going to be static, and everything is going to simply move towards the bird. And this gives you the impression that the bird is moving when in fact everything else is moving. So what do I mean by that? I mean that let's have a shared value x, const x, use shared value from React Native Reanimated. I'm gonna start with 0, and this x is used shared value. A used shared value is driving our animations. It's available on our UI thread, and based on it, we can animate or move positions of things on the UI thread. So what I can do here is probably start by assigning the x of our pipes to be equal to the x dot value, and here x dot value. Let's initialize the x with the width of a screen. If I do width here and reload the application, we will not see the pipes because they are basically outside the screen. If I'm gonna do width minus 50, you're gonna see just a little bit of the pipes. Perfect. Now what I want to do is I want to animate this x value, or basically the x value of pipes, to move towards the left of the screen, towards the bird. To do that, I'm going to start this animation in a use effect, basically when the component mounts or when the game starts. So what I'm gonna do is I'm gonna assign x value. Instead of saying that, hey, you should move towards 0, and 0 is basically the other half of the screen, I will not gonna do that because that will simply move it at the same time, like in the same frame. I'll say move towards 0, but over a small period of time, and I can do that with a hook with timing, and this is already an animation. So the with timing hook I'm gonna import from React Native Reanimated, and if I say like with timing move towards 0 and refresh this one, it doesn't work. Why? I don't know. With timing x value. Did I forget to set something up? Yeah, I think so. Wait a second. Reanimated. Something Something doesn't click in my brain. What happens here? Let's try to clear the server, start it again. Hello. That's very weird. With X value, with timing 0. With timing from Reanimated. Can say over what period of time, for example, duration 1 second, but that shouldn't affect it. Yep, that shouldn't. I'm a bit confused. Let me double check. With timing. X.value. Plugins in Babel config. Used shared value. Anyone sees what I'm doing wrong? Let me check. Check the reanimated version. I don't think it should be that reanimated 3.6.2, and in like today I was testing it with 3.6.2. Maybe, but also no. Let's try, I don't know. Let's do on press. Let me even check if there is a on press. I think it should be. Hello. It's not there. On touch. Hello, hello. So if I do here, x.value equal with timing. Maybe the image is not animated. The thing is that we don't have to transform this to animated components because it supports sending animated values. Should I send simply the X? Yep, boy, I see. So the problem, I'm gonna go back. Thank you for giving me a hint. And no, we shouldn't do animated.image. This image is coming from React Native Skia, and I think most of React Native Skia components, they can receive animated objects. The problem is that I was sending directly the value when I should actually send a shared value. So instead of x.value, I should send the whole x, which is a shared value. and the same one from this one. Now, as you can see, our animation from left to right is working when we restart the screen. The type of so the with timing hook will allow us to move toward a value towards a direction. In this case, we are moving towards towards 0. I think I would like to move it towards -100, to move it behind the screen, even -200 probably, to move it all the way behind the screens. But over a period of time. So now we are saying that we want to move it over 1 second. If I'm going to do it over 3 seconds, it's going to slow it down because it's going to run the same animation, but throughout 3 seconds. The with timing can also have the easing method, like how the timing affects the value. As you can see, by default, it starts slow, it picks up speed, and then it slows down at the end. This is not a linear animation because it doesn't move with the same speed throughout it, but we can change that by providing to the option here easing, and we can import different easing functions from Reanimated, and one of them that I want here is easing.linear. The linear easing will basically move animation with the same speed from the beginning to the end in a straight line. So now I can go back here to -150. And as you can see, from the beginning, it starts and it looks like our bird is moving. I'm not sure what to do with the ground because I should also somehow move the ground. But in a way for it not to, maybe I can have like 2 grounds. pipe. This is the base for the X. Should I do X here? It will also move somehow like this. And I could simply have 2 grounds. This is the base. I can have 2 of them. I can do X. Here I would have to do a, how is it called, a derived value. So actually I'm gonna not animate the ground for now. Just to keep it simpler for us, not to overcomplicate the code. I'm gonna only move the pipes. So now the pipes are moving, perfect. What I can do is when they reach the end of animation, I can move them back where they started. To do that, that basically means that we have to run two animations. So first things first, to run 2 animations, we can sequence them one after another with another modifier with sequence. So if I'm gonna put here with sequence, and then inside the with sequence we can pass different modifiers, they will run one after another. So for example, after we go to the left, let's reset, also using with timing, back to the initial position with. Let's see how this will look. I have to put here a comma. If I restart, come on. Okay, then it will go back there. But it also goes there with timing animations, which we don't really want. I think we can set the duration to 0 to set that, hey, just respawn there without moving towards that direction. And after we are there, what we can do is we can repeat the same animation once again. Or maybe we don't even have to repeat it once again. What we should actually do is we should repeat the whole sequence infinite number of times. So you start from the right of a screen, you go to the left of a screen over a period of 3 seconds. Then you respond back to the right of a screen. Come on. Why? Reload. Let me open it up. Flappy. So you go to the left, then you respond there, and what I want to do is to start over again, to start this sequence again. For that, we have another modifier, which is called with repeat, and we can put any kind of animations, like with sequence, with timing, inside the with repeat. So I want to repeat the sequence, that's why I'm gonna put it with repeat. Inside the with repeat, we have a sequence. At the end, we end it. And here you need to specify as the second parameter, how many times do we want to repeat it? If I provide -1, it's going to repeat it infinite number of times. So let's see what's happening. Okay. Goes there. The next one, the next one, and the next one. Perfect. Amazing. So just like that, we have our map moving. And then we're gonna see maybe we can do multiple sets of pipes so that we don't have empty screens without any pipes. So we're gonna have like 2 sets of pipes going and then respawning and so on. But for now, that's good enough for us. So let's go ahead and do git add, git commit -m. Moving pipes. Perfect. Now that we have our pipes moving, I think the next step for us is going to be to start moving our little bird. So, moving our bird. For that, we are going to have, first of all, the bird is not going to move on the axis. We already figured that out because the bird always stays in the same position. We will only move it up and down. So let's go ahead and define here a bird y as a shared value. A shared one because we will have to animate it. Initially is going to be probably height divided by 2. Let's take this bird y and go ahead and add it to our bird image for the y. Instead of this value, I'm gonna give it bird y shared value. If I restart, everything is back there. The first time I was implementing this, the physics of the bird, I was using the same animation way, like with timing and with repeat and so on. For example, what we can do to simulate the bird falling down is we can say that the bird y.value is going to go, using the timing mechanism, is going to go to the bottom of the screen, which is probably height, and is going to fall over a duration of, let's say, of 1 second. So if I have that, my bird will fall down. If I restart, it's going to fall. And this way, it's perfectly fine. I made it working. You can also change the bird Y position when we tap on the screen to move it up. But at the end, like, the physics was not very realistic. So the next step was, okay, if the physics is not very realistic, let's try to actually simulate the physics here. Because it's not that complicated. There is not a lot of forces that are applied to our little bird. So let's give it a try and use real physics and some real physics formulas to move our little bird. First of all, let's figure what are going to be the physics formulas or forces that are going to apply to our bird. First of all, we have the bird somewhere here, starting at the top, and the bird is going to have velocity, which is the speed of how fast it's falling down. Velocity. Let me do Excel. So initially the bird starts with a velocity 0. The bird will also have the, let's say that velocity, the bird is falling with 10 meters per second. It's going to have initially a static velocity, so that means that we can calculate the position of a bird based on knowing its velocity. So after 1 second, based on this formula, we know that the bird fell down by 1 meter. So this is going to be probably 1 or 10 meters, right? Because if it's falling down with 10 meters a second, after a second, the bird probably fell down 10 meters. Then after 2 seconds, it's going to fall down 10 more meters. So that's how we can calculate the position of a bird at any point in time. Let's go ahead and implement this one, and then we're gonna come back and think about how does gravity apply to all of this. So as we said, the velocity in this scenario is static, and the position is going to move based on the velocity. Okay, let's start by defining the const bird y velocity as, I don't know, 10 meters per second. We're gonna figure out like all of these constants, but for now 10 is going to be enough. Now at every refresh, or at every time we redraw our frame on the screen, we want to update the y position based on the velocity. There is a hook called use frame callback from Reanimated. It's imported here, use frame callback from Reanimated. And this hook, frame, or let's do info. And basically this hook is called on every frame render. It's also having information about the frame that is currently rendering. So let me refresh and check the console log. If I'm going to stop at one point, we see that this function is called very often, and in fact it's being called 60 times every second because we have 60 frames per second. And we also have this value, come on, let me stop it for a second, just not to generate more. Stop it. Yeah. So at every frame we have this value time since previous frame, which indicates how much time did it pass since the previous frame. This is very important for creating smooth animations because we cannot be sure that every frame takes the same amount of time to draw. So what that means is that in fact we're not going to check the position after 1 second. In fact, we're going to check the position after 100 milliseconds. We're going to calculate it based on the formula. Then we're going to check it after 200 milliseconds, 300 milliseconds, and so on. We're going to check it a lot of time, update the position smoothly until we get to this position. So what I mean is that we need this time since previous frame to know how far should we move our bird. Let's take the time since previous frame as the delta time, dt. Now, we have an initial position of a bird that we want to update. So bird.y.value is going to be bird.y.value plus, because we are adding to the position, to the current position, we are adding the velocity multiplied by the delta time. So distance travel is equal to speed multiplied by the time. But this delta time sometimes can be null, so we can check at the first draw or the first frame, the delta time is going to be null. So I can check if it's null here, I will return, I will not do anything. Then I'm gonna simply update the y position of a bird based on the velocity. Let's start it again. No, let's start it again and see what's happening. Okay, our bird falls down very, very, very fast. We can decrease the amount of how fast it falls down by dividing it by 1000, because the delta time is in milliseconds, and simply dividing it by 1000 means that we are calculating velocity in seconds. So that's better. Now we see that our bird is falling down, a bit slower than we expect, but it's falling down. And the velocity or the speed of how fast it falls down is constant, because that's our initial step. We have constant velocity. Every second it falls down 10 meters. You can, by simply increasing this velocity here to 20, for example, you're gonna double the speed. If you increase it to 30, again. If you do 70, it's going to fall a bit faster. So this velocity helps us manage the speed of how fast the bird is falling. Well, this is nice, but in real life, objects do not fall with a constant velocity. Objects start falling slow, and the more they travel, they increase their speed of falling until it doesn't increase infinitely, of course, because there is drag, but if we ignore the drag of the air, the object will increase its speed as it falls down. And that's because the gravity is pulling the object towards it. I think I have here a small animation of demonstrating this. So if we throw a ball up, initially it's going to have a fast speed, and it's slowly going to slow down until it reaches the velocity of 0 meters per second at the top. So at one point it stays static there. Then as it falls down, it increases the speed 10 to 14 to 17, and when it reaches us, it's going to have a 20 meters per second. That's because the velocity is changing, and is changing because of acceleration, where in this case, gravity. Gravity serves as the acceleration of our object. The gravity is the constant part now, but the velocity changes. Let's see how that will affect our drawing here. Now I'm gonna have a velocity here, but I'm also going to have the acceleration. Let me do acceleration at the top because it's going to be static. It's not going to change. So the acceleration of the Earth is 9.8 something. So I'm gonna consider it 10 meters per second at power of 2, which means that acceleration, or like the gravity, will change the speed of falling by 10 meters per second every single second. What does that mean? That means that initially The object, let's consider that it has velocity 0, or let's consider it has velocity 10. So after 1 second, it will travel here. But during this 1 second, it didn't only change the position, it only changed its velocity. So now it has a new velocity because acceleration was applied to the current velocity. So it changed from 10 meters per second, now it's falling with 20 meters per second. That means that the next state is not going to be here, but it's going to be 20 meters from here. 20 meters from here. And in this case, the velocity already will be 30 meters per second. And the next one even further. So that means that as the object falls, the speed of it falling increases. Let's do that in our code. As we see, the velocity is already not a static thing, it's going to be a shared value. So let's do use shared value because we are going to change the velocity. Let's start with 100. Here is going to be bird y velocity dot value. Now it's working the same, but we're going to introduce the acceleration. Acceleration, I'm going to do it at the top as a constant because let's do it as gravity because it's not going to change. Gravity never changes. So let's use it as 10, 9.8 if you want to be more precise. So now the thing is that the position of our bird is going to depend only on velocity. So I'm going to leave this one as it is because here we're changing the position based on the velocity. The only thing that I have to do is I have to do one more thing every frame. I have to increase the velocity based on the gravity. So the bird velocity dot value is going to be equal to bird y velocity dot value plus is going to increase based on the gravity multiplied by the delta time because we want to take into consideration how much should we move in that direction, and probably we should also divide it by 1000 because the delta time is in milliseconds and we probably want to work with seconds. So now if I change it like this, as our bird is falling, it's going to start falling faster. I'm going to start the position of a bird from the top to have a little bit more time for us to see. And at the top, it falls down slowly. Now it falls down faster, faster, and faster, and faster. Maybe you don't see it visually. I can increase the gravity to 50. That means that the earth is pulling faster and the object will speed up faster. I can do it even more. 500 probably is going to be too much. But let's try. Yeah, but it's visible at least. So at the top it's slow, and as it moves down, it increases the speed of its falling. We can also see that by simply doing console log velocity bird y velocity. If I open here, bird y velocity dot value. So initially the velocity is 100, 200, 700, and it increases until, yeah, forever basically now. Okay, so that's the very simple physics that is being applied to our bird. The good thing is that now that we have and we know the velocity and so on, throwing or our interaction with a bird is going to look very similar to the interaction of this person with a ball. We're simply going to give initially a push to the bird, or we're gonna change the velocity of a bird in the opposite direction, and then let the gravity do its work. Let the gravity stop it slowly at the top and move it slowly back down. So this will give us a very natural interaction with a bird. To do that, let's go ahead and, for example, on the canvas, there is on touch. And what I can do on touch is I can set the, as I said, I'll give a velocity opposite to the gravity. So if the gravity is moving down, I'll give it a minus velocity to move it up. So bird velocity equal minus 100. Let's see how it works. So I will refresh. And let's see if I press, as you can see, when I press, I give this bird a velocity upwards. And if I want to give it more push upwards, I can increase like how much I change the velocity to when we touch the canvas. So when I touch, it moves up a bit more. And as you can see, like the gravity takes over. Like the gravity slowly slows it down and starts moving it faster down. Perfect. The problem with this right here, with the on touch, is, I don't know if you can see, but when I press, the background moves a bit slower, which means that we have some frame drops. You see that there is a stutter in the background movement. That means that we have some frame drops, and I can confirm that by opening the performance monitor. And as we can see, whenever I don't touch the screen, the UI and the GS thread are both running at 60 frames a second. When I start pressing, and if I press very, very often, the UI frame drops to 20 frames per second, which is not good, which means that our animation will start looking clunky, as you can see here. And I'm not sure why this is happening. Maybe I have to memorize this function. Maybe the function is recreated every time. But I think that a better approach to this is going to be to start using gesture handler library to manage gestures. And React Native Skia works out of the box with gesture handler. So let's go ahead and set install gesture handler by running npx expo install React Native gesture handler in our project. npx expo install React Native gesture handler. Okay, if I look here, the next step is going to be to wrap everything in this gesture handler root view. So let's take this gesture handler root view and wrap it around our canvas. When we return from our app component, I'm going to wrap it around the root view. And I should make sure to import this from React Native gesture handler at the top. That will only add the gesture handler. Now we also need to add the gesture detector. So that one is going to be gesture detector, which is a component that is being rendered and then can detect gestures. And we're going to also import the gesture itself that is going to allow us to create like the handler. So what I'm gonna do is first, somewhere after this use effect, I'm going to do const gesture equal gesture dot, and here are a lot of gestures like pan, pinch, swipe, and so on. What I'm interested in, a very simple tap gesture. And then I can provide functions to respond to different, to the tap event at different point in time. For example, the on start is going to be a function that is going to be called whenever the gesture understands that it's a tap event. So I can console log tap. Now this gesture, we need to simply send it to a gesture detector that I'm going to use by simply wrapping around the whole canvas. Gesture detector. I'm gonna close this after the canvas ends so that our whole canvas detects gestures, and I need to send here the gesture that we defined at the top. Now if I open it up here and if I comment out the onTouch event from the canvas itself, what we should see, reload, come on. So if I press, we see tap, 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 tap. And our UI thread doesn't even flinch. Like it remains steady at 60 frames a second, and also the RAM usage stays constant. That's perfect. So let's move this bird velocity change inside the tap event, and I will remove it from the canvas altogether. Now, if I start tapping, we see that it works. I think the gravity should be higher to start moving faster. Now I'm going to, as we have the whole what do we have here? Bird physics. Now that we have this bird physics, I'll try to improve a little bit the numbers in order to make it more realistic or closer to the real Flappy Bird, because right now it moves really slow. What I want to do is probably I will increase the gravity. I'll start by increasing the gravity to 900. Let's see what that will look like. And probably the bird should jump higher a bit. That means that I will increase the velocity that it gives, like to 500. Basically increasing both numbers to make it move faster to the top and faster to the bottom. Let's try 1000 gravity. What do you think? I already have fun playing it. Yeah, I think this looks kind of good in terms of physics. Okay, that's good. I'm gonna leave it like this. So gravity 1000, and the, let's say the jump const jump is going to be minus 500. So the jump, let's do jump underscore force. Jump force, we're gonna use it here instead of using, or I can, yeah, it's okay like this, so that I can adjust these values right away from here. Perfect. And the initial bird velocity probably can be 0, and the bird Y let's start somewhere at height divided by 3, like a bit to the top, but not like completely at the top of the screen. Yeah, that looks good. So no matter how much, the RAM is at 162 megabytes, UI and JS thread both are at 60 frames. Perfect. Looks good. I think these values are good. What a great explanation. Thank you very much. I have a bit of experience with game development, even though it was very much like a long time ago. That's what I wanted to say. But yeah, I was working a bit as a game developer. But I forgot everything. So like this is probably the maximum math and physics that I remember, like velocity and acceleration. But I would love to get back to it, to maybe do some more interesting projects with this kind of real life physics. Would be like interesting challenge. Would you be interested in having more projects like this covering like some physics, or maybe we can build some games, some simulations? But anyway, so what would be the next step? So we move a Python, we move a bird, keeping track of a score. Should we try that? Keeping track of the score. Actually, before keeping track of a score, I want to rotate a little bit our bird based on the velocity that it has. So if it moves up, I want the bird to look up. If it falls down, I want the bird to look down. So that means that I'll have to provide our bird a transformation, right? But I cannot add styles here. Can I? I don't think I can. For example, yeah, I don't think. Fill, stroke, image. Image is a Skia image props. I don't think I can do that. So that means that probably I'm gonna have to add it inside a group. I will have to put the image of a bird inside a group, because a group can now have style, right? I will go ahead and comment out the use frame callback for a second, just for me to see the group style. How do you apply transforms in React Native Skia? Image transforms. Transformations. Transformation property. This is on a group. Yep. Okay. So it's not style, but I can transform a group. So I can do here transform. And the transformation is an array. And I can do rotate math.p. Not sure what happened, but if I do rotate 0, where will you be? You're gonna be there. Okay, I think I might understand why, because yeah, at the moment our group, if I would be able to do a background color here, can I? Group color light blue. Will it show me? How can I see the group itself? Field? Should I do a field? Yeah, as you can see, our group basically expands the whole screen. What I have to do probably is going to be to say that the Y and X will not be on the image, but on the group itself, to move the group around. The width and the height as well there. No? You don't want that? Group. What I can do is I can simply change the origin to set the origin of a group, like to leave it like this, but to change the origin to the position of the bird, because the position of a bird is, let's see, origin of a group. Where do you set it? X and Y. So if I will simply do group origin X width divided by 4, because that's the X position of our bird, and the Y position to be bird Y, and remove everything else, of course. Bird Y dot value. Now, if I'm gonna start rotating, will it rotate around itself? Yeah, I see that it does. Maybe not around itself, but around the corner. But it's good, because I can do from minus 0.8, which is going to be looking upwards, to 0.8. So does this. Actually, as you can see, this thing is moving around the top left corner of a bird. I will increase the size of it so that you can see better. So as you can see, it moves around this top right corner. If I want to move it exactly based on the center, I'm gonna have to add the size of the bird to this origin. So X is going to be width divided by 4, but also plus this 64. Let me do it like this. Plus not 64, but half of it. So plus 32. And here bird Y plus 24. Now it should be from the center. 0.50. Yes, as you can see, it doesn't move. When rotating, it rotates around its exact center. Perfect. So now that means that this transform should be based on the velocity of based on the velocity of the bird. Let's see if I would send here a shared value like velocity bird velocity dot value, or even bird velocity. It's not gonna work, right? Dot value. It still doesn't work. Maybe it's gonna work. Bird velocity. Anyway, what I wanted to do actually is to say that based on the bird velocity, we are going to calculate a derived value, bird, how is it called? Rotation. This is going to be a derived value because we derived it from the bird velocity. We calculate it in this function. So let's return bird velocity dot value. So let's take bird rotation, give it to our bird. It doesn't work, it needs dot value, which makes me think that it's not gonna work. And if I change this use frame callback, yeah, it doesn't update. But if we calculate the whole transform in that thing and call this one bird transform, and we return here the whole thing, and give it to the group, to the whole transform. Now it works. Something is happening. Something is happening. Woo, let's go. Let's go. I'm not sure what's happening, but it looks so fun. Oh, and as I jump, it comes back. Now, I know what's happening. What's happening is that the rotation should not be the value of the velocity, but should be calculated based on the velocity. So what I'm going to do, I'm going to use from gesture handler the interpolate function, not from handler, from reanimated. I'm going to import the interpolate, and the rotation, we're going to interpolate the value of the bird velocity, and basically we are mapping a value from a range to another range. So when the bird velocity is the velocity, it goes from minus 500 to 500. So let's do if when it's minus 500 goes to 500, then the rotation when it's minus 500 is going to be, 0.5, and the other way is minus 0.5. I don't know which one is which, so maybe it's going to be reversed minus. Now let's open Expo again. Oh, it looks like it's, oh boy. So funny. And that's because of my, that's definitely because of a origin. Because the origin, you see, it has this shared value, and we know that sending like the full origin should be, if we want it to be animated, we should send a whole shared value, not dot value. So let's take this origin from here and add it also as a derived value, const bird origin, equal use derived value, and we're going to return here this object. Yes, and now we take bird origin and we send it as a shared value to the origin of a group. Now, if I comment out the physics, now it works. Meow. That's so cool. What you can do, like with the interpolation, is to also clamp it. I guess. Type clamp. How to clamp it? Interpolate clamp. Because I don't want the rotation to even grow above the values that I already sent. And it's not in the Skia, but it's in the Reanimated. Let's look for clamp. Interpolate. Extrapolation clamp. Yeah, let's do extrapolation clamp in order to say that, hey, don't go more than minus 0.5 and more above that one. Let's import extrapolation from Reanimated. And now it, yeah, even if the speed is going to be way higher, it's not going to go above. Because I can show you the example if we don't have this one. And if, for example, instead of 500, we're going to have 50, it's going to be clear what I mean by that. You see? That means that the rotation will go beyond like the values that we have here. But if we set clamp, we're basically saying like, don't go above these values. So as you can see here, it moves up and down, but not more than that value. And I would move back to 500 because it's a better value. Nice. Perfect. Let's go ahead and do git add. Bird rotation. Is it getting already too much? Hopefully not. Use then shiftman stuff from the coding train and port it to React Native. That's exactly what I was thinking. Like, I remember a couple of years ago, I was watching coding train and I was having so much fun just looking at him building this. Let's say like they are useless animations or simulations, but they're so fun to build and you learn so much from them, like basic programming or physics or mathematics. And I was thinking like maybe I should do something like that in React Native as well. And definitely Coding Train has a lot of this one. Love his channel. I'm not sure if he's still doing it. Siad is saying, hey Vadim, you and Simon are one of my favorite React Native developers. I've learned a lot from you, especially during November. Thanks a lot. Thank you very much. We appreciate that. If you enjoy what we're doing, make sure to subscribe to the channel, guys, because from the analytics, I see that only 1% of people who are watching the videos are subscribed. So make sure to subscribe and comment down below 1% gang. We're gonna know what that means. All right, so let's go back to our game. And what I want to do next probably is going to be a little bit more tricky. And we will do... Okay, let's try... Should I do first keeping track of a score? Or maybe... Yeah, let's try to start by keeping track of a score. keeping track of the score. When should we increase the score? We should increase the score, if you think like logically about it, is when the bird passes through the pipes. But because the bird is not moving, it's actually our pipes moving on the screen. So in fact, we should increase the score when the pipes move from the left side of a screen to the right side of a screen, like they pass the halfway there, where? Okay, calm down, Vadim. So let's go ahead and do that. That means that we are going to have to increase the score based on this X value. The X is what moves our pipes. That means that we're going to check it when X moves past half of the screen. To do that, my mind says that I don't have it prepared, but there is the use animation, use reaction. How is it called? Animation reaction. Use animated reaction. Allows you to respond to changes in a shared value. It's especially useful when comparing values previously stored in the shared value with the current one. Exactly. We want to compare to check if previous value was on the right side of the screen, but now it's on the left side of the screen. That means that it's time to increase the score. So let's add a use animated reaction. I will, let me change a couple of things in my code. For example, the use effect, I would move it right at the top. I don't know where. Maybe, yeah, before this one. Gesture, frame callback. Yeah, I think that's okay. The derived value for transform and origin, maybe I will move them at the bottom because they are calculated values. I'll keep like, let's say, state or values that change at the top, then our effects, then our functions or gestures, and only then the derived value that we kind of calculate. So now we have the X value here. We are moving it inside the use effect, so it's logical to have the animated reaction after the use effect here. So let's copy it from the documentation. Let's paste it here. Let's import it from Reanimated. And the first one is the value that we want to react to. So that's going to be our x.value. I can simplify this a bit by removing this, just like this, as simple as that. Then we have current value and previous value. So if current value more than previous value, do something. Const console log the map moved to, and here it's, I don't know, current value. So we should see this being called very often, but what we are interested in, restart, is when it passes this half of the screen mark. The half of the screen, yeah, let's check it. Let's check it. So if current value is different than previous value, const middle equal with the width of the screen divided by 2. Now I will do if also the current value is on the left side of the middle of a screen. So if it's less than the middle, and if the previous value was on the right side, it's more then the middle. Then we're gonna do score plus plus. We're gonna increase the score. But previous value can be null. If previous value, but wait a second. Why have the same operation in both cases? I want to say if current value is less than middle, but previous was more than middle, so it should be more than middle. And here I will do if previous value or 0. Or I can default it to 0. I can do here and previous value maybe, if it exists at all. Okay. And I would also have to do, one of them should have an equal sign, because if the current value is right in the center, it might not work. So I will have to do less than or equal on either of them. It doesn't matter. Just to make sure that at least once it takes into account this. So let's reload and see how it's happening. Plus, 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 and we see that it's happening right at that middle, hopefully. Maybe we're also gonna have to deal with decreasing it a bit or adjusting it based on the width of a pipe, but we're gonna figure this out later when maybe we will finish implementing everything and we will polish it. But the thing is that we can detect when this happens using an animated reaction. We are increasing the score, but not actually increasing it. Should we keep the score as a shared value or as a state? I don't know. Let's see in Skia. Can we render text? Yes, we can render text. The text component can be used to draw a simple text. Paragraph. I need probably text, simple text, glyphs. Text path. Oh, nice. Text blob. So let's, I don't know, let's try to define the score as state. Set score. And we're gonna see, maybe it should be a shared value. Use state. Initially is going to be 0. When we do this score plus plus, let's call set score. And we're going to take the current score and we are going to increase it by 1. Maybe it's not going to want to do it because the set score is a state value, and the state value lives on the JavaScript thread. A state value lives on the JavaScript thread. But the use animated reaction runs on the UI thread. So it has access to shared values which are also on the UI thread, but it doesn't have access to the setter that is on the JavaScript thread. For that, I'm not sure how, why we would need a state or a shared value. So if I would still like to continue with a state, probably I would have to use the run on JS function imported from Reanimated. Here we send function that we want to run, and in the second set of parentheses we send the parameters. So this will run the set score function on the JavaScript thread by passing there these parameters. So maybe it's gonna work, I'm not sure, let's give it a try. But anyway, I don't know why I want it to be a state. Anyway, it worked, so let's try to render it on the screen. I will render it as a React Native Skia text. So let's do text here. Let's see the text here. It just needs X and Y. So let's go. Probably after we render the background, maybe even add the bottom because it needs to be on top of everything else. After our bird group, but also in the canvas, let's render the square. Text. Come on. Text. String or text. Square. Probably to string. And we need the X of, I don't know, 100 and Y 100 just to see it on the screen. And then we're going to think about them. And closing as well. Okay, it's object.object. Square to string is object.object. Come on, what? Hello. Hello. And if I do hello and then square, it's object.object. To string, object.object. What? To look. Wait a second. I need to see it right at the beginning. Hide performance. Yeah, at the beginning it's 0, then it's object.object. That means that the way I set it back doesn't work correctly. Set square. What if I do square plus 1 here? Will it work? Square 1, 2. Yes, it works. Okay, perfect. So what do we have? Square. I don't even need this one. To string is going to be enough. For the Y, it's okay. X is going to be width divided by 2 to be somehow in the middle. What else does it have? Font. Font size. What? Hello world? Why it uses font size? I don't understand. The Y is the Y position. Why? How to increase the font size? Font style. How do you give font style and where do you give it? Match font, font style. Oh, match font. So I can play a bit with $40. I don't know. Is not assigned to parameter. Font weight are in string is not to font weight 700. What? Let's try. Let's give it just font. Okay, it worked. So, yep. Color, can I change color here? I don't know. But I'm okay with that. Almost. It's very hard to center it like this. Okay. It's something. So the fill, if I do here a group, do a fill, it's going to use that as a color. I don't know. Okay, we have something. At least we have a scoring system. I realize, our score increases too soon. It increases when the pipes passes the middle of the screen. However, we moved the position of our birds a bit to the left of the screen. So we should increase it when the pipes passes the position of a bird. So if I check the bird, it has x equal to width divided by 4. Let's use this as the bird position dot x. Let's define it somewhere here as the const bird position as an object x, and it will also have y. For now it's only x. Should it be bird pos? Yes, bird pos x. And we're going to use this bird position in the animated reaction to check not the middle point, but let's do middle here, bird pos dot x. That's why it should be declared a bit more to the top. Bird y. It's getting a bit messy. I'm getting a bit tired. We have a bird pose and we have bird y, shared value, but it's okay. So let's just see if the timing is right. Yeah, now the timing is right. Like when the bird passes through the pipes, that's when we increase the square. That's good. And if we later decide to move the bird to, I don't know, the position 50, like very close to the left, or even like 10, it's still gonna work, and the matching, like it's going to be synchronized. Okay, that's good. Let's go back to width over 4. Okay, nice, looking good. Okay, so that's our git status. Score. Okay, we have a score. The next one is going to be collision detection to stop the game when we touch something. CS says, subscribe and turn on the bell. Thank you very much. Which VS Code theme are you using? I don't know. Should be the material theme. I have a video about that. It's the material darker. Material theme think it's this one. Oh, this one, material theme. And from it, it's specifically the darker one, I think. Whew. All right, so collision detection. There are a lot of collision detections that we have to do, but I think the collision detection is also going to be an animated reaction, but this time on the bird Y. So every time the bird Y position is going to change, because the X never changes, the X remains the same. The bird Y position goes up and down, and every time it happens, we should check if it collides with something. So let's define here, let's do here the scoring system, and we're going to define below the collision detection, which is also going to be an animated reaction that will be triggered when the bird Y dot value is going to change. So we are going to get back the current value and the previous value. And let's basically do the following. Basically, if current position, if current value is more than the screen height, that means that the bird went to fell down, right? Let's do a simple console log, game over. The simplest collision detection is going to be with the ground, because that is detecting a collision between an object and a line. So what we do here, let me open up this one. So after it passes, it's game over. So we simply compare the Y position of our object with a line, with the height of the screen. In fact, we don't need the height of a screen because there is also this ground. So let me do the next thing. Let me define a shared value const game over equal use shared value, and it's going to be false. Now let's simply, when we do that, let's simply do game over dot value equal true. Now I want to stop some of the movements when the game is over. For example, I want to no longer do the, where is it? Frame callback when we are moving the bird around. I want to stop that from happening. So let's stop the execution of this function when the game is over. So if game over is true, then I don't want to do anything. Now we see the game over only once. The thing is that it happens when the bird is already below the screen. I think we're gonna have to do in this check, where is it? In collision detection, when we check the current value, if it's more than height, we should subtract here the height of our base. In the height of our base, if we look in the base, height 150. So let's do that here. Oh, it's getting already interesting to navigate. So height minus 150. Now I expect the bird to stop when it touches this base. Does that make sense? I think so. Maybe we can do 100. Boom. And it crashed. Okay, that's good. The next step is I want to also stop the map from moving, right? To do that, our map is moved by this use effect at the beginning of our application mounting, and we are starting it using this with repeat, with sequence, and so on. If only there would be a way to stop this animation on the X value. Well, the good thing is there is. So in the collision detection, when the game is over, and actually I'm gonna add another, not to have to call this, okay, let me actually call it first. I can call cancel animation from React Native Reanimated on the X value. If I do that, hopefully it's going to work. Should I do cancel animation X? Yes, it works. So we are canceling the animation. A better way would be to watch for the game over value changed using an animated reaction, and only then cancel this animation, because we don't want to do it like always like this. I think so. Yeah, so I'm going to add here, let me copy paste this one, but now it's going to look for game over dot value, and if current value or currently it's game over, but previously it wasn't game over, previous value it wasn't game over, that means that we can cancel the animation on X. Will that work? Boom, stop. If current value and previous value, not were, stop. Yes, perfect. 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 Okay. So we have some kind of game over state here. I was trying to show like a pop-up to the user, and I was trying to use a simple alert, but of course we're not going to be able to do it here because we are on the UI thread. So I was thinking, okay, if we're on the UI thread, we're going to use a run on JS. We're going to use the alert here, and we're going to pass here game over. But for me, it didn't work. So I'm not sure why. When we crash, it still crashes the application, this alert. So what should I do better? Anyway, I'm not gonna alert anything. But whenever we press on the screen once again, I'm gonna restart the game. What do you think? Let's try it like this. So I'm gonna do in the gestures, when we tap, I'm gonna check if the game over value is true, restart. Otherwise, jump. We already know how to jump. How to restart? So jumping still works. And when the game is over, I want here to restart. How? By let's doing here const restart game equal a function. Let's call it here. And what should happen when we restart the game? Well, first of all, we need to reserve the position of a bird. So bird y.value is going to be to its initial position. What was the initial position that we set? Bird y, height 3. So let's see if at least the bird, restart game. I think it should be a worklet. No, or yes, it should be a worklet. So simply doing use worklet, will that fix? Boom. Or just worklet. Because this function, we need to define it also on the UI thread so that the gesture can call it. Flappy Bird. Okay, now it works. So if I simply do worklet here, we can call it from our gesture. We reset the bird y value. We also should reset its velocity. So bird, because if it was falling before, I want the velocity. How is it called? Oh, come on. Bird y velocity. I'm getting lost already. Dot value is going to be equal to 0. And what else? What else? The game over is going to be value is going to be equal to false. We're gonna restart the game. The score is going to be equal reset to 0. What else would happen? But here I'm not sure if it's gonna work. Yes, because set score should run on GS. Run on GS, set score and value 0. And the next step is we should restart the animation of moving the pipes. The animation moving the pipes was started here in this use effect. Let's take it out into a separate function called const move the map. And in the use effect, we're going to call move a map. And the same thing we will do when we restart the game. We will call move the map. Doesn't want to work. Maybe also run on GS, move a map like this. Let's try. Boom. We restart. We start over moving the map. It comes back to this position. I'm not sure why, but I will do the following. I'm going to change the value of x to the initial value that it had. X is going to be width. So now it crashed. If I restart, we start over from x0. So we crash, game over, we start again. You have cancel animation X twice. Cancel animation. Yes, that's true. That means that if I'm canceling the animation based on an animated reaction over the game over, I don't have to do it here as well. So that was the benefit of putting into a separate one, because I'm going to change the game over in multiple places, not only here. This is only floor or ground collision detection. I'll probably have to also do the same for the ceiling. Like if I go very high up, I would also do game over, but I can do it also here. If current value is more than height, or if current value is less than 0, that means that we went too high. So if I'm gonna go, boom, game over, and restart from the beginning. Boom, crash. It just restarts it very fast. So okay. Now the interesting part, we need the collision detection between the bird and the pipes. How do we do that? Well, we know the position of a bird. We know the position of the pipes. We just have to put them together somehow and do the detection. I can start very simple. I can say if the bird position matches the position of the pipes, then let's consider it as game over. So that means if this is current bird position, if current value is equal to x dot value, and x is our map, x is our pipes. If it's equal, or let's say, it shouldn't be equal. It should be current value is more or equal than the x value. Let's do game over. So that would mean that if current value is less or equal than x value, what's happening? Did you stop working? Current value. If current value is less. No, it should be if it's more than x value. And why are you stopping right now? Current value and x dot value. Oh, because I'm checking the bird y value. I should work with bird position dot x. So bird position dot x, good. Now as soon as I go here, and it actually works based on the middle, as soon as that happens, game over. X value, x. So what I need to add here, oh boy. Let's search for some formulas for collision detection, because what we actually as I remember from game development, we should basically consider them as either a collision between a circle, which is our bird, and different rectangles, like different rectangles like this. So knowing the position of rectangles and knowing the position of a circle and its size, we can calculate which of these it is touching, it is basically colliding with. So I think that's what we should do. So let's go ahead and do here collision detection, a sphere or circle and rectangle. Okay, so I'm also trying to think like which one is going to be easier, circle and rectangle, or rectangle and rectangle. What was the previous one? Collision detection, rectangle, rectangle, point, collision detection, point, rectangle. Maybe I should just consider the bird as a point. I think it's going to be easier because I don't have to take into consideration the radius and so on. What's even easier? Yeah, let's try with point and rectangle. So checking for collision with circular object is fairly easy, since it's the same distance from the center to their edge in every direction. Rectangles require a bit more complex algorithm. Let's say we have a square, rectangle X, rectangle Y, rectangle width and height. To see if a point is inside the square, we have to test, is the X position of a point to the right of the left edge? Then we have to check if is the X position of a point to the left of the right edge, if it's below and at the top. If all of these are true, then the point is inside. Let's look at testing the left edge first, since the default mode for rect command draws from the upper left corner. Okay. So let's look at testing the left edge first. Left edge first. This is point, this is rectangle. Okay. Let's do the following. Oh, complicated. So we have bird X and bird Y. I want to draw, instead of an image, I want to draw a simple circle. Circle. It's not on the background, but it's going to be on top of a bird. Circle. With kind of the same things. But a circle has radius. Skia. Circle. Center radius. Cx. Cy. Why it's not X and Y? I don't know. And radius of, let's say, 5 pixels. Okay, we see the dot there. Let's try to recenter the center of a bird over actually the center of a bird. I'm going to do that using a derived value. So let's do const bird center is going to be a use derived value. And this use derived value is going to return us the x, which is going to be x.value, and y is going to be not x.value, bird position dot x, and bird y dot value. I'll start with this, which is going to be the same exact values, but I'm going to adjust them in a second. Now for this dot that we see on the screen, let's go ahead and say that the dot we are tracking is going to be bird center dot value dot y, and then bird center dot value dot x. And you are not moving. Oh boy. Because they should be bird. Yeah. They should be two different derived values. So bird center x and then bird center y. And bird center x is going to be this one. And y is going to be this one. Let's work with the center just to have clarity. Bird center y and bird center x. Now as it moves, it follows the bird, but I will recenter it to the middle of the bird by adding half of our bird width and height. So 64, 48. 64. For the x, we are going to add 32. And here, we're going to add 24. Okay. Now, the dot is exactly in the center of the bird. Circle. Color. Can I do that? Color red. Will it work? Yes. Or maybe white. Purple. I don't know. Or I'm going to simply remove a bird altogether and have it as a red dot. Now we're working with a red dot, which I can increase a bit in size. And then we are going to, we have a red dot. The rectangles are going to be the two of our pipes, right? Let's again work with them. I want to draw two boxes on the screen, just for us to know what we're working with, to have a visual representation. So in the paths, I'm gonna have what? Polygons for the rect, x, y, width and height. So here, sim, we're gonna have a rectangle. That is going to be our first box. Rect. is our pipes. Pipe offset x width and height. Oh boy. Why is it 103? Maybe 104. It's supposed to be. Width and height. Pipe. So let's go ahead and add these two to a constant, pipe width and height. Const pipe width is equal to how much? 104. Const pipe height is equal to 320, something like that. Oh, 640 pipe width, and this one is pipe height, which should be a bit different. 640. Let's go to the top. 640. I think I'm gonna not draw the rectangles there. I'm gonna use like what we see here because it's the same x, y, width, and height. Now let's go ahead and check a little bit of the collision detection algorithm here. So the first thing, as we say, like we have to do 4 checks for every single pipe. So let's go ahead and do here in our collision detection. Use animated. Top pipe. Let's work with the top pipe, or even let's start with bottom pipe. We're not gonna work with bird position, but center. Bird center. X or Y? X. Dot value. Let's go ahead and check the first one. If all of these are done, let's look at testing the left edge first. Since the default mode, okay, draws from upper left corner, the left edge is at rectangle X to the right of a rectangle. So if point X, and our point X is bird, I'm gonna do it like this. If bird center dot value is more than the rectangle X, and we're talking about the bottom pipe, let's check what is the Rx of our bottom pipe. I'm gonna go here. I'm gonna check for the where we render the pipes. The X of a bottom pipe, well, the X is the X, so it's going to be the same. Rx is going to be simply x dot value to the right of the left edge. So the bird is to the right of the left edge. Okay, perfect. Console log to the right. So when we go here, we get to the right, which is basically what I had before. Which is the left edge plus the width to the left of the right edge. So right over left, left over right. Okay. This is going to get interesting. So then we have, this is the first check. Then we need this one. Px is point x. It's our bird value dot x. Rx is going to be the x of our pipe, and Rv is going to be the width of our pipe. So that's our pipe width. So now we know that the point is exactly in between the two things. It's but it should be and here, yes, and reload. What I'm gonna do probably is maybe I can now we need to check if it's below the top and above the bottom. These are the last two checks. Below the top, py is the point. It's our bird center y dot value. Ry is the Ry is our bottom pipe y value. So it's this one. We need to take it exactly how it was there. Ry. And here again, py is our bird center y, is the point we calculated for. Should have and here. Ry is going to, again, we're going to take it from the y of the bottom pipe. Plus the height of the pipe. So that's going to be pipe height. So now we should properly have, game over, detection with bottom pipe. Let's check if that works. So with the top one, we don't yet have detections, but with the bottom one, we should. So if I'm gonna go and touch it, doesn't work. Where is the pipe offset? Pipe offset. Maybe I should do it at the top somewhere. Oh, now it worked. If I'm gonna go touch it from the top, it also works. If I'm gonna touch from the side, it also works. So it works. Oh my God, I'm so happy. Oh boy. Amazing, perfect. So the same way as we have here for the bottom pipe, we should do with the top pipe. We can copy paste it, top pipe, and the only thing that will change, the bird position will not change. Like this will will remain the same. The X value is not gonna change. The pipe width, pipe offset, not gonna change. The only thing that is going to change is this value, like where is the top, the Y value from the top pipe. The Y value from the top pipe is pipe offset minus 320. So here, instead of this thing, we're gonna have pipe offset minus this, and here we're gonna have this. Now I think we should have proper detection for both of these pipes. Here it works. Works. I think it works. Perfect. So now I can remove the dot and add back the bird. But just remember that we are, checking the collision based on the center of the bird, which is nice, which works pretty okay. Oh my God, it works. Yeah, boy. Okay. So it wasn't actually that complicated when we have a formula. Most probably we can improve this thing by having a list of obstacles as X, Y, and X, Y, width and height, and then looping through them and checking their value. So I think that's what I'm gonna try to do now. Let's go ahead and create a derived value with const obstacles, which is going to be an array of obstacles that we need to check using this detection. So let's do use derived value. And it's going to return an array, or let's do const response equal to this, all obstacles. Now let's do add top bottom pipe, then add top pipe. Let's go ahead and do all obstacles dot push, and we're gonna push an object with values that are very similar to this one: rectangle X, rectangle Y, rectangle W, and rectangle height. Or even easier, X, Y, height, and width. These are the four values that four values that we need to provide about one obstacle. So for the bottom pipe, I'm gonna go into the if statement that we have here, bottom pipe. Let me check. So the X is going to be X value, the Y, one second, yeah. So the X is going to be X dot value. The height is going to be pipe height. The width is going to be pipe width. And the Y is going to be, I'm going to go and take it from actually the Y where we render it. So pipes, the bottom one, the Y is this one. So in here in the obstacles. I'm gonna add it here. And now I should do the same for the top pipe. X is going to be X value, Y is going to be different. So let's go and take a different Y from here, this one. For the top pipe, I'm gonna change the Y. Now we have, now at the end, we should return all obstacles. We have top pipe and bottom pipe. In the collision detection, what I should do is I should basically I'll define a function const is colliding with rect, or let's say is point colliding with rect. This is going to be a function that will do most of the things that we have here. Let's do it like this. But it's going to be much more easy to work with because we're going to have here a point and a rectangle. Then this one becomes the point.x. So this one becomes point.x. The same here point.x, here point.y, and here point.y. On the other hand, we have rect.x, here rect.x multiplied by rect.width. Here we have rect.y, and at the bottom rect.y plus rect.height. So it's very similar to the formula that we see here. Rx, Rv, Ry plus R height. So if this is happening, I'm going to simply return true. Or I can simply return the whole thing, like return this. Because we use it in an animated reaction, this should run on the, maybe it's gonna work, but we'll see. If it fails, we're gonna make it a worklet. So what I want to do right now is I can check for the bottom pipe. I don't even need like to check separately for the bottom pipe and for the top pipe. I only have to do const is colliding, and I'm gonna take all the obstacles dot value, and if at least one of this obstacle, which is rectangle, if at least one of them is point colliding, where the point is going to be, it needs an x with bird center.x, and it needs a y with bird center y dot value, and it needs a rectangle, which is our rect. If at least one of them is true, then it's going to be is colliding. So if is colliding, game over equal true, or game over dot value equal true. So maybe here, like I lost you a bit, I realized. But instead of basically doing this for two of them, if in future we're going to have more pipes and more obstacles, it's going to be hard to check for all of them. Instead, we create an array of these obstacles at the top, and then we loop through them and check if our point is colliding with at least one of them. Let's check right now. If I'm going to open, yeah, I think it's it actually needs here to be a worklet. worklet, because we are calling it from the UI. Okay, it doesn't actually work with the top one. Does it work with the bottom one? No. Bird x.value rect. Let me check console log point and rect here. Point and rect hvxy. Oh, it shouldn't be with but w and here h. hvxy. hvxy. Works. Boom, works. So perfect. Now it works. Amazing. Amazing. Oh, that was hard. Where is the console log? I don't need it anymore. Let me do git add git commit collision detection. Oh, perfect. So another thing that I want to add for the game to be more interesting is for the pipes, like for the gap, to be at different position. Right now it's always in the center of the screen, but I can change that by simply changing the pipe offset. So we see that we have here pipe offset. And now if I'm going to change from a normal value to a use shared value 0, let's see what do we have. I'm going to check where we are using this pipe offset, and I'm going to use dot value. And where else? Here, pipe offset dot value. Pipe offset dot value. Oh, it's not going to work. It's not going to work. Pipe offset. Pipe offset dot value. It's not gonna change. That's the problem. Because if after the first reset, or let's say this is the scoring system with the X, but I can add here also the way to change stuff around. Because if the current value is less than 0 and the previous value is more than 0, I want to change the offset with a random value. So pipe offset equal to dot value equal to math dot random multiply by 10 or multiply by 100 and then minus 50 to be able to move up and down. It's still here, but you see, like it changes not when it has to change. It only doesn't update properly because I am sending here to the to the y of the top pipe, it should be a shared value. So again, another shared value. Const pipe. Let's do pipe top pipe y equal use derived value. And the value is going to be top pipe y. Let's check. It's going to be top pipe y dot value, and I'm gonna take it from here, put it in this derived value. The same for the second one. Bottom pipe y is going to be bottom pipe, and the value I'm gonna copy it from here for all these calculations. So now it should work. Why it changes ever so slightly here? If previous value and current value is less than 0, and previous value is more than that, for 400 and 200. What? Current value. This is the X. Change offset. I want to change offset only when they go to the end of the screen. The change offset works correctly. Value. Anyway, why does it change when... Okay, I know. I should check not based on 0 here, but based on minus 100 maybe. It's still not how I want it. When we render pipes. Yes, because I still use value. I should use the actual shared value without dot. Yeah. Now it should work. Perfect. Okay, now it's getting more interesting. Okay. Boom. Okay, now it's fun to play. Okay. So we have change offset. change offset for the position of the next gap. Let's go ahead and do git add git commit -m random gap position. Whew. I'm already very happy with where we got so far. What do you think, guys? Pretty cool, right? Sometimes it goes sideways, but most of the time it works pretty well. Anyway, I think there is a lot of opportunity for improvement here. Maybe we can cover some of it right now. Not a lot, but at least some of it. Like with a bird position being an object. With only X, I think, where do we use it? Let's check in bird position X, bird position X, X, X. Maybe it's smarter to do bird position X equal to width over 4, because we have bird Y and maybe even bird X, not bird position. Bird Y, bird X. Now let's check where we use it and make sure to change it to bird X simply. Here, bird X. Here, bird X. Now it makes a little bit more sense. Reload. Hopefully it's still working. Come on. Oh, I need here. Okay, bird center. Let's do that, this one here, right after the positions. Bird center. Where do we use it? Let's check how many places we are using it. Is colliding bird center. Bird center. We are no longer rendering this simulation. So it's really only used in this collision detection, right? So I would say that let's get rid of it because we are using only there. Let's not calculate the derived value out of it, but simply create it there because we don't need it anymore for rendering something on the screen. So I'm going to copy them from here, cut them from here. I'm gonna scroll down where we use them. Let me paste it at the top of this function and think about creating an object wrapper center equal to X is going to have this value, bird X, and Y is going to have this value. Now I will remove these two things and I have a center which I'm gonna replace here. Instead of bird center x.value is going to be center.x, and here center.y. But as you can see, our is point colliding with React expects an object with X and Y. So why not simply sending here center? Just like this. Let's see if it still works. It works. So we got rid of two derived values. Next thing, bird, yeah, we have bird y, bird x, bird velocity, the pipes, pipe offset. Pipe offset is good. Top pipe y, bottom pipe y. Move the map. Maybe this x is not very clear what it is. So let's do pipe.x, pipe x, and let's check here where we have this x. So whenever we access x, let's do pipe x dot value. Here, pipe x dot value. Be careful with this refactoring, because sometimes we can break things. But if you are careful of replacing all of the instances, here, cancel animation on the pipe x. Pipe x. Pipe x, the next one is also pipe x. And that's it. Now it should work. Boom, we restart, it restarts. Okay, nice. What else? What else? Obstacles. Like these obstacles, it makes sense to have this push, but I would simply have an array here with values right away, because it's going to be much easier to see. But it can be a bit confusing. So you can leave it like this, but what I'm going to do is I'm going to get rid of the array itself. I'm going to get rid of these push things. I'm going to leave object right away. I'm gonna get rid of this push as well with this. I'm gonna get rid of return obstacle, and I'm gonna turn this one into an actual like return array. And at the end, I'm gonna close this. I need to put comma here. So now it's simply an array with two objects. I can as well remove a return statement and these brackets, and it's even easier. So bottom pipe, top pipe, like this, makes sense. Let's see if it still works. Top pipe works. Nice. Bottom pipe works. What else I don't like? This one is nice because it's a reusable function that we can use based on any point with any rectangle. We can check if it's colliding or not. Yeah, now it's a little bit more clean. Let me go ahead and do git add, git commit -m refactor. You can keep track of a high score system. What if you, for example, want to increase the speed of, if you want to increase the speed of how fast the pipes are moving? Well, first of all, what influences the speed of how fast the pipes are moving? It's this duration, because if I would do here 1000, you're gonna see that these pipes are moving very fast. I don't even manage to do it like 1.5. So what you can do is we can take this duration, put it into or let's do a shared value for pipe speed, right? Const pipes speed equal use shared value 1. If we're going to increase the speed, we want to increase the value of how fast the pipes are moving. So that means that the duration divided by pipe speed dot value. So if we increase the pipe speed, the duration is going to decrease, so the speed is going to increase, basically. But now, yeah, at this moment, if it's 1, it's going to go with this speed. If we increase it to, for example, 2, that's going to be double the speed, as we can see. Perfect. Now the last thing is when do we increase the pipe speed? Well, first of all, I know for sure that when we do restart game, when we restart the game, we're gonna do pipe or speed. How is it called? Pipe speed equal dot value equal to 1. We're gonna reset it to 1. But when in our scoring system, I think, or you know what we can do with it? Pipe speed, I can take the score, which currently is a state variable. I don't know why I made it a state variable. But pipe speed can, instead of shared value, it can be a derived value. A derived value that will be calculated using an interpolation. We're going to interpolate the score. So the higher the score, the higher the speed. When the score is 0, I don't know, score 10. When the score is 0, the speed I want it to be 1. When the score is 10, or maybe 20, I want the speed to be 2. Maybe when the score is 10. Let's just see how it works. And in this case, if it's a derived value, I will not have to reset it in restart game. It's going to depend on the score. So now, as we move, as the score increases, the pipes should move faster, I think. I hope. I don't know if that's happening, so I'm gonna increase the speed not to 2 but to 5. So in this situation, I'm gonna know. It's not gonna change, and I know why. Because we set this animation of the pipes . Yeah, we set the animation of the pipes once. Move a map. Maybe I should not have a with repeat, but instead call movie map again when we end it. What if here we're gonna do cancel animation on pipe X, and then call again move map? Will it work? I don't know. Let's try. Probably it's because of move map, which is not a worklet. Because without it, it's not gonna crash. So let's try to do run on GS move map. Come on. Move map. Move. So the sequence, when calling movie map, I think it should start by going there. And it doesn't need the repeat because we're gonna call it over and over again. I don't know if it's gonna work, but let's try. Back into the game dev, yes. Okay, now it works. And I can definitely see that the speed is increasing. Okay. So I will clamp it probably like a 20. It's going to be 2 to increase the speed, but relatively okay. How are you doing, Andre? How is your work at Callstack? Okay, now I can play. I have what to do today. But actually today Netflix released the new season of F1, which I can't wait to go and see. So I think that we are going to have to end the stream. But it's so satisfying. I was thinking to add also like sound effects, but I didn't. So this would be your homework, to add sound effects using Expo AV. Now I can play. Oh, you have 2 accounts? You're answering from the same name but different avatars. Working on native dev. How are you? I'm good as well. Doing content, working. This week we started the incubator program, during which we're gonna help founders launch their startups. That's also something exciting. But yeah, anyway, guys, I think that is it for today. We have managed to do a lot of things. Let me do a git add, git commit, increase the speed. I'm gonna make sure to publish this on GitHub and link the repository down below so that you can play around and continue working on it by adding different features, maybe adding a nicer end screen, maybe keeping track of a high score, but should also not be very complicated. You would simply store it on the local storage using async storage and compare it every time you finish the game. I'd also add sound effects that would improve this application by a lot. And I think that's it, like nothing more. Maybe you can play around with the sprites of numbers. We have here 0, 6, and like all the numbers as sprites. So if you're interested, you can try to render them, but that's probably going to be a lot of if statements. But anyway, thank you very much for joining. I hope you enjoy this one. Let's see, maybe in future we're gonna do more of this kind of non-traditional React Native applications, maybe some games, some simulations, some creative programming. I would love to prepare something for you. So if you're interested, make sure to let me know what projects you'd like me to build in future. And I'm gonna try to do that. Anyway, guys, I'm gonna go check out the F1. If you're also into F1, today is the premiere of Netflix, and next week we have the first races. So very excited about that. Anyway, subscribe to the channel, turn on the notification bell. We're going live every single week.